Okay, so in this video, we're going to look at connection of resistors in electric circuits, right? The connection of resistors in electric circuits. How are resistors connected in an electric circuit? So a resistor is simply a wire or a material that offers resistance, that offers opposition to the flow of current. So there are two ways resistors are arranged, or there are two ways they are connected in an electric circuit. Number one is the series connection, and secondly, we have the parallel connection. So these are the two ways, the two basic ways in which resistors are connected in an electric circuit. So for the first form of connection, which is the series connection, resistors are said to be in series when two or more resistors are connected end to end. So if you have a connection whereby the resistors are connected end to end, we call that a series connection. So for example, what you have here is an example of a series connection. The resistors are connected end to end. This is resistor 1, resistor 2, resistor 3. They are connected end to end, right? So in a series connection, it's very important that you know that the same current flows through them. So the same current I flows through the three resistors. The same current that will flow through resistor 1 will also flow through resistor 2, will flow through resistor 3. So the same current flows through them, right? And they have different voltages. So each of them will have different voltage. So the potential difference will differ while the current remains the same. Current that flows through them is the same. So to calculate the total resistance here, your total resistance RT will be equal to R1 plus R2 plus R3. So in a series connection, what you just do is add all the resistance together, and that will give you your total resistance. So the total resistance is equal to R1 plus R2 plus R3. And also, it's very important that you know that the same current flows through them, but they have different voltages, right? So the next form of connection is the parallel connection. So resistors are said to be in parallel connection when two or more resistors are connected to a common terminal. When two or more resistors are connected to a common terminal. So this is the common terminal here. You have R1, R2, R3. They are connected to what? This common terminal, right? So this is what we call a parallel connection. Parallel in the sense that they don't touch each other. So they only meet at what? A common point. They are connected to a common terminal. So for the series connection, the resistors are connected end to end. For the parallel connection, they are connected to one terminal, right? So one important thing that you should know is that different current flows through them, right? So if a current I is flowing through this circuit, a current I1 will flow in here, another current I2 will flow through here, another current I3. So different current flows through the three resistors, and they have the same voltage. So the voltage, the potential difference is the same, but different current. In the series connection, the current is the same, but the potential difference what differs. They have different voltage, but they have the same current flowing through them. So so the total resistance here will be 1 all over RT, which is the total resistance, is equal to 1 all over R1 plus 1 all over R2 plus 1 all over R3, right? So this is how to calculate the total resistance in resistors that are connected in parallel, right? So let's take examples to illustrate this. Three resistors of resistance 1 ohm, 2 ohm, and 4 ohm are connected in series. Find the equivalent resistance. So when resistors are connected in series, what does that mean? It means that they are connected end to end. So the total resistance will be equal to 1 plus 2 plus 4, which are the three resistance, right? So that will be equal to 1 plus 2 plus 4, that is equal to 7. So the total resistance is equal to 7 ohms. They are connected in series. So when resistors are connected in series, the total resistance will be equal to R1 plus R2 plus R3. It means that they are connected end to end. Then here's another question. If three resistors, 2 ohms, 3 ohms, and 5 ohms, are connected in parallel, so the connection here is that they are connected in parallel. So if they are connected in parallel in a circuit, calculate the equivalent resistance of the combination, right? So the total resistance in a parallel connection is 1 all over RT, which is the total resistance, is equal to 1 all over R1 plus 1 all over R2 plus 1 over R3. So 1 over RT will be equal to, my R1 is 2 ohms, which is what I have here. So that's 1 all over 2 plus R2 is what? 3 ohms. So that's 1 all over 3 plus my R3 is 5 ohm plus 1 all over 5. So the next thing I want to do is to look for the LCM of 2, 3, and 5, right? So let's look for the LCM of 2, 3, and 5. So what can go? 2 can go. 2 divided by 2 will give me 1. 2 divided by 3 is cannot, so I'll drop the 3. 5 divided by 2 is cannot, I'll drop the 5. What can go again? 3 can go. Here will be 1. 3 divided by 3 will give me 1. 5 divided by 3 cannot, I'll drop down the 5, right? So the next thing that can go is 5. Here is 1, 1. 5 divided by 5 is what? Is 1. So therefore the LCM is 2 times, the LCM is equal to 2 times 3 times 5. 2 times 3 is 6. 6 times 5 is 30. So the LCM is 30. So I'll come here and write this bar here and put my LCM there, 30, right? So 30 divided by 2 will give me 15, right? So times 1 will give me 15. So that will be 15 plus 30 divided by 3 is 10 times 1 is 10. So that's 10 plus 30 divided by 5 is 6 times 1 is what? 6. So that will be 6. So my 1 all over RT is equal to this. So 15 plus 10 plus 6, that will give us what? So I bring out my calculator and press that. 15 plus 10 plus 6, that will be equal to 31. So my 1 over RT will be equal to 31 over 30. So since I have 1 over RT is equal to 31 all over 30, the next thing I will do here is to cross multiply, right? So when I cross multiply, RT times 31 will give me 31 RT is equal to 1 times 30 will give me what? 30, right? So my RT will be equal to 30 divided by what? 31. So RT will be equal to 30 divided by 31. If I do that in the calculator, 30 divided by 31, that will be equal to 0.9677, right? So that will be equal to 0.9677. That is approximately 0.97 ohms. So this is my answer to this question. So my total resistance is equal to what? 0.97 ohms. So when they are connected in parallel, this is how you solve. So let's look at the last question here. Calculate the total resistance in the diagram below. Calculate the total resistance in the diagram below. So if you look at this diagram, you would see that 1, 2, 3, 3 ohm, 4 ohms, and 5 ohms, they are connected in parallel. And so you would want to resolve that first. So when you resolve this, it will not be in series with this, right? So the first thing I want to do is to resolve these ones that are in parallel. So let me put my solution here. So for the parallel connection, for parallel connection, for the parallel connection, for parallel connection, 1 all over ROT, which is my total resistance, is equal to 1 over 3 plus 1 all over 4 plus 1 all over 5, because they are connected in what? They are connected in parallel. So my 1 all over ROT, which is the total resistance, will be equal to. So first of all, let's look for the LCM of 3, 4, and 5, right? So I have 3, 4, and 5. So what can go? 3 can go. 3 divided by 3 will give me 1. 4 divided by 3 cannot, I'll put down 4. 5 divided by 3 cannot, I'll put down the 5. What else can go? 2 can go. Here will be 1. 4 divided by 2 will give me 2. 5 divided by 2 cannot, I'll drop down the 5. What else can go? 2 can go. 1 divided by 2, I'll drop down the 1. 2 divided by 2 will give me 1. 5 divided by 2 is cannot, so I'll drop down the 5. And the next thing I would want to do is to divide by 5. So here will be 1, 1. 5 divided by 5 will give me 1, right? So the LCM will be 3 times 2 times 2 times 5, right? So 3 times 2 times 2 times 5, that will be equal to 60. So the LCM is equal to 60. So I'll come here, write my bar here, write 60. So 60 divided by 3 will give me 20. 20 times 1 will give me 20, right? Plus 60 divided by 4 will give me 15. 15 times 1 is still 15. Then 60 divided by 5, 60 divided by 5, that will be equal to 12. Times 1 is 12, so that will be plus 12. So this will be 1 all over ROT, which is equal to 15 plus 20 plus 12 will be what? 20 plus 15 plus 12. 20 plus 15 plus 12, that will be equal to 47. So that will be 47 over 60, right? So the next thing I want to do is to cross multiply. So if I cross multiply, when I cross multiply, ROT times 47 will give me 47 ROT is equal to 60. So ROT, which is the total resistance, will be equal to 60 divided by 47, right? 60 divided by 47, that will give me 60 divided by 47, that will be equal to 1.276, which is approximately 1.28. So that is equal to, ROT will be equal to 1.28, right? So with this, I have resolved the parallel connection to be in series with this. I've resolved it to be a single what resistance. So what I now have in essence, I will now have something like this. Here will be the 2 ohms, and here will be the 1.28 ohms, which is what I've resolved here, right? And here will be the 6 ohms. So what I've just done here, is that I've resolved 3, 4, and 5, which are in parallel connection, into a single resistance. This is the total resistance that we got, 1.28 ohms. So I've resolved it to be a single resistance, which will now be in series with this. So for the parallel connection, we've gotten this. Then for the series connection, my ROT, which is the total resistance, will be equal to 2 plus 1.28 plus 6. 2 plus 1.28 plus 6. And that will be equal to 2 plus 1.28 plus 6. That will be equal to 9.28 ohms, right? So this is the final answer to this particular question. So the total resistance in the diagram below is 9.28 ohms.